begin with lab module 2, which is input and output interfacing using LEDs and switches. So we have just passed our lecture week number 3, and you have already learned the basic of input and output using LEDs and switches. So for today, this lab, we're going to do programming and do some manipulation using the input and output for PIC16F. And before we start, first, we're going to review the lab module, and we're looking at the objective first. We have two objectives. The first one, you will write C language control LEDs using PIC16F 877A. So this is the microcontroller of choice. And you're going to write C language program to control LEDs connected to PIC. This one will be explained later for during the exercise example. And then for number 2, design C language program to control and manipulate LEDs and switches using PIC16F 877A. After you have completed the first objective, then you proceed to the second one, which involve input. So you're going to manipulate the switches and observe the output from the LEDs. And the microcontroller will stay the same, PIC16F 877A. And then the component, XA compiler, computer unit, and fixed lab. So these are the 3 important items. So make sure that you have these 2, XA and also PIC lab. And another one, NP lab. So we go first with just a brief introduction, since you have already learned the concept of input and output through lecture. So we're going to look at the first one, which is digital input. By digital input, we mean switch. So we are connecting switch to the digital input of our microcontroller. So basically, what we have learned, it can be full high or full low configuration. So this means that we can give it or set it to 5 volt, which is high, when the switch is pressed, or we can set it to 0 when the switch is pressed. So the configuration, we call it active high, and then the other one would be active low. So the microcontroller can read the status and then determine the action taken when that condition or parameter has been achieved. So looking at figure 2.1, this is the schematic for switching to input. So looking at diagram, so you can see the input is connected to pin RB0, RB1, and then RB2. So this one will go to the microcontroller. And then this one, KC3, KC1, KC1, connection to the switch, respective switch, switches. Okay, we have 3 switches, switch 3, switch 4, and then switch 5. So you can see the configuration here. You need to identify whether it is active low or active high. So when we press the button, input here become high or low. So need to determine so that we can write properly on the coding side. Okay, so need to check. This is the setting that you need to follow. Try to follow this setting. And then, since you are doing this simulation using fixed lab, you need to set the properties value for the switch, whether it is active low or active high. So this one we will review later. And then we have output. So when we talk about output, we're going to concentrate on the LED for this particular lab module. So as you already know, the most common and most used indicator in electronic device. So the LEDs can be figure whether it is can be figure as in active low or active high. So as in figure this one, figure 2.2. So these are two available configuration that you can connect to PIC. Yeah? We have active high, and the other one will be active low. So just to make things easy, yeah? If we are doing active high connection, so make sure that the output here must be high, or 5 volt, or 1, or true. So when you are dealing with high, okay, make sure that the signal is 1, 5 volt, or true. And then if the signal is active low, this one, decide. You need to write, or you need to write 0 or false. So need to identify. So this one, you need to the configuration that need to be matched with your program code. And then if you refer to figure 2.3, possible connection of LEDs in PIC microcontroller. So this type of connection you can see from here. Typically, we have more than one. If you want to assemble, connect more than one LED, so this is the type of connection that you can use. So starting from here, you can see this one, resistor pack. So this type of connection, so it means that the connection will start from RA1 and then going to RA2, and then this one not related. Okay, just this one RA2. Okay, so do you have any question? Since you already know the basic configuration and how to connect, do you have any question before we proceed? Okay, question. So we go to the exercise example. Slide number 1. Blink the LEDs. So there will not be any input to the microcontroller. So you just write code to give output. Okay, so the condition is that all LEDs that connected to port D, you need to use or you need to connect the LED to port D. And then the condition, blink every 1 second, which is the on side must be 500 milliseconds, and then after that, turn off at 500 milliseconds. So together, the blink will be in 1 second. So this is the program example. You can copy this and then paste it to your MPLAB. So you can see here, double slash means that comment section. So you need to write just to inform the section what is the purpose of the session, okay, so that it will give you some information regarding the program. So you can see here, okay, this one doesn't have any effect on the program. So we start with include the compiler XCH, and then setting of the PIC configuration, and then we define the crystal oscillator at 20 megahertz. So when you are writing code with 20 megahertz, so make sure that the hardware also must be 20 megahertz. Okay. So definition, we can skip this part, just the basic output only. So we need to display output on port D, so this means that we need to configure direction register, which is trace D. So everything should be 0 because we want to configure port D as output. And then trace D, then we can proceed to clearing up initial value of port D. Okay, so we set everything in port D equal to 0, and then we go to continuous looping. Okay, so continuous looping, we just follow the requirement by turning LED on and off with interval 500 milliseconds, and then after that will be the end of the program. So continuous looping. Okay, so far do you have any question? Okay, so this is the window, MPLAB window setting, window output. So as you can see here, I've already created project. This one represent for that module number 2. So I think you have no problem. Okay. So before you do anything, you need to create a project. So make sure that the name of that particular project can be connected to the lab module, which is module 2. And then the source file, I name it as lab 2 exercise 1. Example, this one, example 1. So we just copy the whole thing and then paste it. So make sure before you do anything, make sure that fixing lab appear here. So this means that the program here, the MPLAB, the program will be linked to fixing lab. And then you go to the fixing lab window, then do the same thing. Make sure that you check everything. Clock must be 20 megahertz. And then this debug button is pressed. And so make sure that the connection exists between these two software. And then the module also. So the module here, so we need to use output from port D. Okay, so use output from port D. So make sure that the setting here, right click, go to properties, click properties, and then everything RT0 up to RT7, and then the configuration must be active high. Why active high? So we refer back to our program. We are writing one, okay, because we want to turn on. So by writing one, so this means that the configuration must be active high. So we start by compiling. Okay, be a success. So that happens. So we proceed to debug. Okay. And then if you refer bottom side, so you can see okay, fix him will appear here and then run again. Can view here. So if we want to check whether the signal is actually 500 milliseconds, so you can go, you can set for oscilloscope, and then you can connect to any of the available pin, whether RT7, RT5, RT4, RT0. So only one channel is sufficient. I use R4, RT0, try to use RT1. Okay, the maximum value is 200 milliseconds. So you can see from here, this is high, this is low. So this is signal, trigger signal from channel 1. So you can see from here. So the fine box, you can see here the grid represent 200 milliseconds. So we have 1, 2, 2, 2, 4, and then the other one half. So 100, so 500 millisecond. 500 millisecond on, then 500 millisecond off. So you can also check using the oscilloscope. Okay, so that one will conclude for exercise number 1. Do you have any question? Okay, so no question. And then we proceed to exercise number 2. So for this part, we're going to evaluate the input input and also the output, and then observe the output using the LED. So for this part, we're going to observe specific LED, and then the input, we are using two switches. Okay, so input will be two switches, call it SW1 and SW2, switch 1 and switch 2. And then the output LED must be connected to pin RC2. So the condition is that when switch 1 is pressed, so when we press switch 1, the LED on RC2 pin will turn on, and then if we press another switch, W2, the LED from RC2 will turn off. So basically, we press, then we release, RC2 LED will turn on, and then if we press the other switch, W2, then we release, RC2 will turn off. The condition is stated here. So the definition, okay, so I already teach you, mention during lecture. So we can represent, you can see from here, we have two lines here, hash defined as W1, RB0. So this means that we are representing RB0 as SW1. And then the second one, we are representing RB1 as SW2. So after this, okay, after this will be sufficient if we just call the name here. No need to call RB1. So this one will be easier, especially if you're dealing with multiple pin. Easy for you to distinguish the respective pin. So you can see here, okay, the current program code example here is not the same because only the important part are shown here. So this means that you need to include other section, important section that will enable the program. So you can see here, okay, the routine, only the input definition, and then after the main subroutine, we will go to pin configuration, okay, through direction register 3C and 3B. Okay, so the input is located at RB0 and RB1. So this means that we're going to use two pin from port B at RB0 and RB1. So this pin must be configured as input. So when input, this means that trace B0 and trace B1 must be 1 and then 1. So you can use this type of setting configure, or you can use individual code. So we set trace B as input, and then for trace C, we only use RC2. So you can do this. We set for the port for 3C as output. Okay, so you can only do this type of configuration provided that the pins are free. Okay, so you are using only pin RC2, and the rest is free. You are not connecting. You are not connecting the available pin to the rest. To the rest of the load. It can be either LEDs, can be switch. So you are not connecting. So this means that you can use this code. Okay. If you are setting, if you are connecting port C to other type of device, so you need to access, configure individual pin. Okay, so right now we are not using any other pin other than RC2, so we can use this type of configuration. And then we set 3C output, 3C as input, 2 bit from port B2, and then we can proceed to clear out initial value from output, which is RC2. So this one we are accessing individual bit from port C. And then we go to continuous looping. So we start with conditional statement, if statement. If switch 1, so where is switch 1? Switch 1 is at RB0. So double equal to. So this means that we are comparing value, not assigning value. We are comparing. If switch 1 is equal to 0, so we are giving 0. So 0 means that the configuration switch is active low or active high. So this switch you need to figure out. Okay. So we are giving 0, not 1. So this means that the configuration must be either active low or active high. So this one you need to figure out. Okay. If switch 1 is equal to 0, so compare. If true, then we proceed to switching RC2. RC2 will turn on. So right now you can see we are giving port RC2 output high. So the LED must be in the form of configuration active high. So we want to turn on active when the signal is high. And then if switch 2, this one is switch 1, then the other one is switch 2 is equal to 0. If the condition is true, we turn off RC2. And then the process repeat continuously. Okay, so do you have any question? Okay, so if you don't have any question, we try to observe example from here. I have already made the program. So this is the program for test number 2. And then again, make sure that you check. Since you are doing simulation with the team, make sure that the program is listed here. So check. So you can see the configuration, the color configuration. So the while everything color coded. So easy for the programmer to write program. So we go to build the project and then make sure that the output must be successful. Okay, successful. Okay. So but this one we need to remove first our skirt. So this is the setting for exercise number 2. So again, make sure that you check. This one must be connected to RB0 and then RB1. And then the other one, put only RC2. The rest is not important. Okay, we want to observe output from RC2. So make sure that you configure correctly. Okay, so if everything is perfect, you're confident with your program, and then the build process of the been successful. So we go for debugging. Okay, observe the PIC sim here. If you're running this correctly, so the flow will be similar to this one. Okay, run target. Okay, so the condition is if we press RB0, RC2 will turn on. Okay, RC2 will turn on, and then press again RB1 or switch 1. This one is switch 1, switch 0, and then this one is switch 1. Okay, off. On, off. Okay. Nothing happen. Okay, nothing happen. So must be alternate. Okay, so when you satisfy the program, finish, click here. And also if you want to modify the program. Okay, do you have any question? Okay, and then if no question, we proceed to exercise number 3. This one you do it by yourself. Okay? If you have any problem, you can contact me. Okay? So I will try my best to help you. Make sure that you do that early as possible. Okay? Do not wait last minute. Okay, so this one, exercise number 3, for example. Okay, the input, we are still using SW1 and then SW2, and then output. So this one, we add another input, LED. But this time, we are connecting two LEDs on pin RD0 and also RD1. So two LED, RD0 and RD1, and then two input, SW1 and SW2. The condition is that when SW1 press, LED from RD0 will blink one time. And then if switch 2 is pressed, the LED RD0 and RD1 will blink 2 times. So pressing one, LED RD0 blink 1 time. Pressing switch 2, LED RD0 and RD1 will blink 2 times. So we can do the same thing. We define switch 1 RD0, switch 2 RD1, and then we proceed to configure. Okay, since LED, we are going to connect to port D, so make sure that the direction register 3D must be configured as output. And then input at 3B, only 2 bit, RB0 and RB1. So this part here must be configured as input. And then we clear out RB0, RB1, RB2. RB0, RB1. Okay. So there are no RB2. Okay. So even though it included here, but it will not cause any error. Okay, so you can remove this one. We are using only RD0 and RD1. And then after that, okay, this is the continuous looping. For switch 1, is condition for switch 1 is true. Blink LED from port D bit 0 1 time. So the delay here is set at 500 milliseconds. And then after that, if switch 2 condition is true, okay, we do by blinking 2 times. Okay, so the delay here is at 500 milliseconds perspective. Okay, so this time LED from RD0 and RD1 will be turned on. Okay, so that's it. Do you have any question regarding lab exercise? Example number 3. Soalan, do you have any question? Okay, so this one you better try it by yourself. Okay, no question. Oh, very confident. So we proceed to the design question. Okay, so this part you need to do exercise, you need to submit, and then the submission must come together with a report. Okay, so basically, this is the design question. Okay, you have 3 questions. The first one, if the switch SW1 is pressed, the LED port D will do running right from left to right. Okay, so this one, okay, check first. Okay, so this is the current one. Okay, ignore the previous one. This one come from the previous session. So, okay, make sure that the question here is similar with the one that you are uploading. You can check. Okay, so the correct one. we refer back to number 1. If switch 1, W1, press the LED at port D will do running light from left to right. So when you press switch 1, so the switch 1, the location of switch 1 is not mentioned, it's not stated. So you are feel free to use any port available. Okay, so if switch 1 is pressed, LED. Okay, so LED only connected to port D. So we do running light. So running light, so start from left first. The first bit turn on and then turn off. Second bit will turn on, turn off, and then the third bit, then followed by the rest of the following bit. Okay, so the connection is that. And then for switch 2, if you press switch 1, the connection here will happen. And then for switch 2, LED at port D will blink 5 times with 500 millisecond delay. So press port D, switch 2, the LED port D, okay, still the same port, still the same LED at the same port, it will blink 5 times, okay, with 500 milliseconds of delay. And then this is the final one, final question. It's the switch, W3. So this means that 3 input. Okay. W3 is pressed. The LED at port D will do running light from right to left. Okay. So that's it. I think very easy. Most familiar with one, but opposite direction. Okay, so do you have any question? Okay, so if you don't have any question, this is the question that you need to do. Okay, so you need to answer for question 1, question 2, and question 3. And then submit a report related to the design question. 3 design questions shown here. And then the format of the report, okay, there are 6 formats, which I will explain to you right now. Okay, so you will start by attaching a front page. Okay, so you can obtain the front page here from our GC page here. Okay, so this is the front page. Only here, not the second one. Okay, so write down the module and then the title and then your group name. First and then the second with their respective metric number. Okay, so this one need to attach together with your report. Okay, so maximum 2%. Okay. Special case upon permission, okay, can be considered. And then for number 2, you start by explaining introduction by briefing only related to the question and not to the whole topic. Okay, so make sure that the introduction must be correct and precise. So the introduction must be related to the design question and not to the scope of the lab. Okay, need to distinguish between these two. And then for number 3, write down the methodology. The methodology need to have these 2 items: the schematic, connection, for switch 1, switch 2, and then switch 3. So if you are connecting switch 1 to port D, make sure that the schematic must indicate port D connected to switch 1. Okay, so must be complete assembly. Okay, try to include clock circuit. What is the value of the clock? Okay, so this one is important because the clock frequency is related to your program. And then the power circuit, make sure that you properly label okay, where is the connection to the power circuit. And then MCLR, okay, the one that you have learned, memory clear, reset button, and then the rest will be the input and then the output. So this one must be handwriting, in handwriting. Okay. So everything must be in handwriting except for this one. Okay, this one. Okay, and also this one, 4 and 6. Okay. If you want to write appendix using handwriting, also can, but make sure that your handwriting is recognizable, can be read. Okay, so I repeat again. Your report must consist front page. Okay, so front page, and then the report must have introduction. Okay? Introduction focusing on the briefing on the question itself. Okay, not the scope of the lab. And then the methodology side, just include these two items, schematic, and then the other one would be the flow chart. Okay? The flow chart, okay, how does the flow design according to your program. One flow chart. Also in highlighting, so the flow chart need to have start first and then initialization, and then go to decision making if variable. So you need to properly draw them. And then after that, result and discussion. Okay. So you write down result and discussion according to your design question. And then another one, you must include demo, video, presentation, okay, for lab. Okay. The duration must be within 3 minutes. Do not exceed more than 3 minutes. So the format must be in MP4. Okay, so the format must be in MP4, and okay, so this one we need to review. Okay, this one more accurate. Okay, so this one team member maximum. Okay, so we proceed to format number 4. Must contain result and discussion. You need to write down and then try to include, not try, mandatory, need to include a demo video for your program. Okay, so that you don't have to explain anything. Do not explain everything here. Only focus on the output. Okay, so you start from the MP lab. Okay, you start from here. Okay, explain something. Like for example the clock, and then the input, and then the main program, and then after that you build, and then you debug, and then you proceed to this one. Okay, and then explain this one. Okay, what type of connection, what configuration, connect to pin where, input what happened, and then after that when you debug, okay, your program need to produce output according to the design question here. Okay, so for number 1, show result for number 1, and then for number 2 and 3, and do the same thing. Okay, but make sure that the duration must not exceed 3 minutes. Okay. Just concentrate on the output only. Okay. The rest no need to explain, but make sure that before you proceed doing anything, make sure that you video, you mention your name. Okay, you mention your name, your partner group, your partner in your video. So it will be easy for us to identify. Okay, so the video only concentrate on the output. Okay, must not be more than 3 minutes. Okay, between 3 minutes. And then the last one, the report must have conclusion. Okay, based from your work, try to conclude, okay, what you have learned. And then this one, attachment. Okay, appendix. Need to attach copy of the program from your MP lab. Okay, so everything must be handwritten except certain part, video, copy. Okay, the rest must be handwriting. Scan in PDF version. We prefer PDF version. Upload to Google Form in group of 2. Okay, so video demo should be uploaded via YouTube or sharing a link in a form. Okay, so this form. Okay. So if you want to share through YouTube, you need to include the link of your demo video in your report. Okay. So when we click that link in your report, it will take us to the demo video in YouTube. Or you can put the video in your private drive. Make sure that you enable sharing setting as viewer. Okay, make sure that we can view your video, okay, so that we can give proper mark. Okay. So when you have uploaded the whole thing, make sure that you click this link. Okay. So you need to register. So you go to this form. Okay, so your name, your partner name, and then special case with permission from coordinator. Okay, must obtain permission from coordinator, and then group number, and then lab report, and then video link. And then due date. Due date here 20 next week. Okay, 22nd of April 2022, the due date. Okay, do you have any question regarding the format? Okay, silent is modern. So this one I want to share with you all. Okay, another one. This is the rubric for your lab, starting from lab 2 to lab 4. Only for lab 2, lab 3, and then lab 4. OEL, not related. Okay, so your marking will be awarded according to the criteria shown here. Okay, the highest mark will be 4, and then the lowest, this one weightage. Weightage. Okay. So this is the total mark. Okay. For section, each of the related section, this is the maximum mark that you can obtain. Okay. So make sure that you follow. If you want to have good grade for your lab, you need to follow this the requirement shown here. Okay, so do you have any question you want to ask? Okay, so you can do. Make sure that you submit the report. Okay, on. Okay, let me check that again. Okay, 22nd of April due date. Okay, must be sent. The final date must be 22nd. Okay. If you submit after 22nd, 23rd, penalty will be awarded. Okay. So late submission will cause mark reduction. So don't know okay. If you send late, okay, more than 1 week, 2 weeks, and 1 month, so the marks might be highly high. The ratio of mark being deducted will be increased. Okay, so make sure that you follow the deadline given here. Okay, this one for G2b. So do you have any question? Soalan?
Sir, I have a question.
Okay, agree.
May I know the input? We must use the push button or we use the switch?
Better use push button.
But use push because the design question want us to do running light. But when we use push button, when we release the push button, the signal
will turn off, right?
Yeah. Cannot stay.
Okay. So let's say if you are using switch, right? okay, you press switch button. Okay, so LED will turn on even though you release the press. What happen if you press H2, switch 2?
If I use else if, then the switch one, the code that I read for switch one will run if the switch 2 is open also.
Open meaning what? Connected, connect.
Yeah.
So you are not using push button, you are using switch. You press switch 1 and then you release the switch. Okay, the condition will still be true, right?
Yeah, will stay.
Okay, so even though you release your finger, okay, even though you release your finger, the condition will always be true, and then the LED will do the running. Okay, so right now the condition is still true, right? The condition is still true, right? Even though you already remove your finger, the condition is still true, right?
Yes, it's still running.
Still running. So if you are switching S2, this between question 1 and question 2, do you wish to do separately or you want to include together?
I include it together, but if I switch on switch 1 and switch 2 together, the condition switch 1 will run, switch 2 will not run.
Okay. But what happen if you press switch 2? Okay, so you press switch 2, since switch 1 already true, okay, and then you press switch 2, two condition will happen, right? Switch 1
No.
already true.
Just one condition will happen only.
What condition?
Only switch 1 will happen if two switch is on.
Let me write first. Okay. Okay, so you are not using, so this is for push button, right?
Yes.
Okay, when you press, you leave your finger. The condition normally become when you press 1, after you release the button, it will be 0. Okay, so if you use switch, okay, when you press, when you connect, okay, the condition is true, and then after you leave your finger, the condition is still true, correct?
Yes.
So this is switch 1. Okay, switch 1 already true. Okay. Let me connect first my pin, my fan first. Okay, so we go back to your question. Okay, so you want to use this switch. Okay, so the first condition, if switch 1 equal to let's say active low, okay, 0. Then LED equal to 1. This one 85. Okay. So if condition is true, okay, this one I better change. See, yeah. Okay. Make it. Okay. If switch 1 is true, then LED is true. This one for condition 1. Okay. And then you want to use F. Is F. As if. Else if. And the one switch 2 is true. And then LED. This one LED running. Okay. So run. LED. Run. Okay. So can you see something here?
Huh?
Do you notice something different here? Okay. So because you are using switch, okay, so because you are using switch, if you press switch here, okay, the condition will become
Switch 1 is on.
still on, correct?
Yeah.
Okay. And then what happen if you want to connect to switch 2?
Switch off, switch 1.
You need to do manually, right?
Yes.
So basically, this one is not just my opinion. Okay. For this, if you want to use, it's up to you. This
But
one is not efficient because you need to do more than one time. Okay. So just like a less switch. Okay. You need to press, and then you release, and then you observe. Okay. And then after that, if you want to observe switch 2, you need to press again, switch 1, and then you need to press switch 2 again. Okay. Let's say that if you forget to release this switch, and then at the same time you connect this one. Okay, so this means that two conditions will be true.
But if we use push button, we cannot remain the signal. So when we release it,
you can remain the signal provided that you continuously press.
Okay.
Okay. But for your experience, okay, if you want to try, feel free to try. Okay.
Actually, I already tried.
But if you are using switch, the switch here, not button, the momentary switch, okay, the condition will happen here. Okay, so you need to remember. Okay, if you want to enable switch 2, you need to switch off switch 1 first. Okay, if you want to observe switch 1, you need to remove first. You need to turn off first switch 2. Okay, if either switch is turned on, so your program will be conflict because two condition true, you know what to do. Okay, so you can try to experiment. Okay, which one the best? Okay, any more question?